Okay, so today we'll solve two questions from functional analysis. One is from question number 38 from Gate 2023, and the other one is from Gate 2022, question number 15. Okay, so let's first start with question number 38 from 2023. Okay, so today we'll solve Gate 2022 question from functional analysis. This is the question number 38. It's saying that let C00, it's denoted a one norm space. It's saying that all this is infinite string such that xi is a real number and I varies, this index varies it over natural number such that xi is non-zero for only finitely many indices. Means this space is contains a infinite string one-sided so that after finitely many all entries are zero. So it has means finitely supported. Now it is saying that let x1, x2, x3 is in this space and define the norm for any point. It's taking the supremum because there are only finitely many points. So supremum we have, they are bound finite. So supremum by supremum of mod xi each coordinate. Now define two operator from C naught naught to C naught naught. What is saying? F is taking point x1, x2 dot 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 xn dot dot dot. It is mapped to 1 plus 1 into x1 comma 2 plus half into x2 dot dot n plus 1 by n into xn dot dot. And g is defined like this: x1 by 1 plus 1, x2 by 2 plus half, like that, and xn by nth coordinate is xn by n plus 1 by n. So two operators are defined. Now it's saying that four options are given. You have to check means F or G are continuous or not, right? So this is the question. For this is the NPTEL reference. Okay, so let's try to solve this one. So what it is given, C naught naught a space given. It is saying that all such x1, x2 like that, xn dot dot such that xi not equals to 0 for only finitely many. Indices I. And where I belongs to natural number, right? So this is the space. Now define this two operator F from again the norm. What is the norm? Suppose x is this x1, x2 dot xn. Then what is norm of x? It is the supremum over all xi such that I is a natural number. Then define two functions f from C naught naught with this norm. This is denoted by norm x infinity to C naught naught via f of x1, x2 dot dot xn dot dot So where it will map to 1 plus 1 into x1, 2 plus half into x2 dot dot n plus 1 by n into xn dot dot. And how j is defined? C naught naught with infinity number 2, C naught naught g of x1 x2 xn dot dot. It is x1 by 1 plus 1 comma x2 by 2 plus half dot dot xn by n plus 1 by n, right? So first check that f or g continuous or not. So what is, they are linear operator here. Continuous means they are bounded or not, right? So we'll show. So first we will show. So we have to check that we will show that f is not continuous. Means we will show that basically this is the meaning that it is continuous. Norm of x infinity, this will not hold. For all x in C naught naught, this will not hold. Means this is the saying that f is continuous. F is not continuous. This inequality will not, means there does not exist any C such, or means there does not exist C such that this will hold. Okay. So suppose this will hold, right? So let's prove it by contradiction. Suppose it is true, means there exists C positive such that norm of fx infinity is less than C times norm of x infinity for all x in C naught naught. Then what will happen? So let's take some particular point. Choose this sequence. Choose or some y n to be the en, means this can 0 0 0 0 0 1 0 0 0 0 this at the point nth place, right? So note that these are only non-zero at one places, so they are, so note they are in C00, right? Because they are only non-zero at one places. Now what is this norm at 1, norm at n? So this has only one non-zero component, so this has, so supremum of all other are 0, it only 1, so norm is 1. Now if you put this, check norm f of yn, so what is f of, so basically en, definition of f is this, so whenever in the xn plus it's 1, so it will be n plus 1 by n, n plus 1 by n. Now we have assumed that suppose there exists C such that this will hold. Now put it here, and this is true for all x. So therefore norm of f yn should be less than C times norm of yn, or so this side it is n plus 1 by n less than C times this has norm 1, right? Or it is saying that n plus 1 by n is less than C. C is some fixed number, and this is true for all n, right? All en, this is true for all n. So now you can take n to be large, means now take n tends to infinity. Then this will not hold, right? Left hand side become infinity, this cannot be bounded by constant. So this, we get a contradiction. So our assumption, what we have assumed, suppose there exists C, some this will hold. So this will not hold, means, so therefore, so our assumption is wrong. Means there does not exist C positive such that norm of fx is less than C times norm x for all x in C naught naught, right? Means f is not continuous. Okay, so this one is done. So f is not continuous. Now you have to check G for G. So G, what we will show that G is continuous. Now we will show that G is continuous. Means there exists C positive such that norm of Gx is less than C times norm of x for all x in C naught naught, right? So you have to show this inequality, then we are done. So let's check. Okay, so what is norm? First note, what is norm x infinity? So this is supremum of xi such that I is in natural number, right? So therefore what it is saying, so each xi are less than this norm, right? This norm for all I. So this is true because norm x infinity is the supremum over all xi. So each xi are less than the norm x infinity, right? Now let's take this one. Denote yi to be xi by I plus 1 by I. Means what I have taken the, what this will map, because this I have taken this to be the yi, xi by 1 plus 1, so this is y1, this is y2. Means what is this? G of x1, x2, this I am taking to be this y1, y2, like this. This I have taken the y. So note, and I is what? I are bigger than equals to 1, right? So what is mod of yi? So this will be mod xi by I plus 1 by I. So means this is xi by I plus 1 by I. And note that as these are bigger than 1, so this is always less than xi, right? And we know mod of xi is less than norm x infinity, so this is also less than norm x infinity. And this is true for all I, right? So this inequality. So what we have got? So norm yi is less than norm x infinity for all I. Now if you take the supremum, so supremum over mod yi such that I in natural number, so this should be also less than this. And what is this quantity? So this is supremum over, what is this? So this is what we have chosen this yi. Why I have chosen that xi by I plus 1 by I. Xi by I plus 1 by I. So these are less than norm x infinity. And what is this quantity? This is the g of note that what is this side? What is norm in look? What is norm g x? So it will be the y1 up to yn dot this one, right? So supremum over mod yi such that I is in natural number, and this xi by I plus 1 by I. So look that both sides are equal, right? So this side and these both are equal, so this is the norm gx infinity. So norm gx infinity is less than norm x infinity for all x, right? This is true for all x in C naught naught. So we have shown this one. So what is the constant here? Here constant is the 1, C equals to 1. So we have shown this inequality with the constant C equals to 1. So which means that G is continuous. Right. So then which option is correct? So we have got F is not continuous and G is continuous. So the first option F is continuous but G is not continuous, so it is not true. Option B, F is not continuous but G is continuous, so option B is correct. Both G is option C, both F and G are continuous, it is not true. Neither F nor G is continuous, so option D is also not true. So option B is the only correct option. Okay. So we have done the question number 38. So what we have done basically, two functions, two linear operators are given from C naught naught. These are basically compactly supported functions, and we have shown that first one, which is F, which is not continuous, and G is continuous. Okay. So if there is no question, then we can move to the next one. Yeah, you note one thing, that C00, this is not complete. Right. So that's why it's not a Banach space. So it's a non-linear space. Okay, now let's move to the next one. Okay, so today we'll solve Gate 2022 question. This is a question from functional analysis. It is a question number 15. It is saying that let X be a non-linear space and X not be the unit wall of that non-linear space X, means all such X such that norm of X equals to 1. And saying that if X naught contains two distinct points X and Y and the line segment joining them, then which of the following statements is true? Okay, the 4 options are given. We'll check which one is correct. So in order to solve this is the NPTEL reference. Okay, so let's try to solve this one. So first note that this we will first eliminate options. So what is the given? X, it's a real non-linear space. And what is X naught? X naught is all such X in X such that norm of X equals to 1. And what is given? That if X and Y belongs to X or X naught such that they are distinct, X naught equals to Y, then the line segment joining X and Y will be there. Means then let's set it this Tx plus 1 minus Ty should belongs to X naught, while T belongs to this 0 1, right? So this is the given condition given. So let us take one example first. Let take R2 with norm equals to norm 1, L1 norm. And what is this? So means X belongs to R2. So X will be of the form sum x1 comma x2, and norm of X, one norm of X is defined to be mod x1 plus mod x2. And so what is the X naught unit ball in this norm? So X naught will be basically, or let me X naught, this time it will be R2 naught, means all such X in R2 such that norm of X with respect to one norm should be 1. So basically what is this? X belongs to R2, X equals to x1 comma x2 in R2 such that x1 plus mod x2 equals to 1. So how this set look like? Okay, so this is the basically, so this is R2 and this is R2 naught, so this is 0 comma 0 and this is R2 naught. I mean, this is the unit ball in R2 with respect to this norm 1. This is the point 1 comma 0, this is 0 comma 1. So this is the unit ball look like. So let's take this one, take 1 comma 0, let me call it to be x and y to be 0 comma 1. There belongs to in R2 naught, and we need this condition will so that this R2 with norm 1 is a this space, means we will satisfy that if you pick these 2 points, then the entire line joining them will be in this unit ball. So note that what is this point then, tx plus 1 minus ty. So how this will look like, it is t1 comma 0 plus 1 minus t 0 comma 1. So it is t comma 1 minus t. Let me call it zt. Then what is the norm, L1 norm of zt? So it is basically the zt is look like t comma 1 minus t, so it's mod t plus mod of 1 minus t, but these are positive because t is in 0 1. Let's take t in 0 1 or close 0 1. So they are positive, means t plus 1 minus t, so it is 1. So this entire zt is lying in this space R2 naught. So zt belongs to R2 naught for all t in 0 1, right? So R2 this norm 1, and if you choose these 2 point xy, then it satisfies the condition what is stated in the problem. Now look what are they are asking. So let's first check the option B. It is saying that norm of x plus y is same as norm x plus norm y, and x and y are linearly dependent. So option B, what it is? First check that, so this is the x we have taken out to be a 1 comma 0 and y to be 0 comma 1. So what is x plus y? It is 1 comma 0 plus 0 comma 1. So it is 1 comma 1. What is this norm of x plus y? So it is 1 plus 1, it's 2. And what is norm x? Norm x is 1, also norm y is 1. So it satisfies this condition. Norm of x plus y equals to norm x plus norm y. And what the next one is saying? That x and y are linearly dependent. But is x and y are linearly dependent? But x equals to 1 comma 0, they are not linearly dependent, right? And y equals to 0 comma 1 are not linearly dependent. So option B is false. So option B is false. Now let's check option C. Option C is saying norm of x plus y square equals to norm of x square plus norm y square, and x, y are linearly independent. Option C. So we have calculated norm of x plus y square. So norm of x plus y is 2. So norm of x plus y square is 2 square, it's 4. And what is norm x square? As it is 1, so it is again 1, and norm y square, it is again 1. So therefore norm of x plus y whole square is not equals to norm x square plus norm y square. So therefore option C is again false. Now let's check option D. What is option D? Saying that norm of x plus y equals to 2 into norm x into norm y, and x, y are linearly dependent. Norm of x plus y, we know it's 2. So this is as, and norm of x we know it's 1. Norm of y is also 1. So it satisfies norm of x plus y equals to 2 norm x norm y, and it is saying that x, y and y are linearly dependent, but again they are not linearly dependent, but x equals to 1 comma 0 and y equals to 0 comma 1 are not linearly dependent. So option C is again false. Option D. Now we have to, it's remain to check option A. So it will be true, but we will check that. So it's remain to check option A. Norm of x plus y equals to norm x plus norm y, and x, y are linearly independent. So option A is remain. So this will be true, so I have to prove this. So let's check what will be the, for general, what will be norm of x plus y. To show, this is to show norm of y and x, y are linearly independent. Right. So what is the condition it's given? So it's given that whenever x and y are in x0 and x0 equals to y, then the entire line segment should be in this, right? For all t in 0, 1. So as we know, for x, y in x0 and x0 equals to y, tx plus 1 minus ty is in x0 for all t in 0, 1. Right. So take this particular choice of t, take t equals to half. Then what will happen? So x by 2 plus y by 2 will be in x0, which means norm of x plus y by 2 is 1. So which is same as, I forgot to write all these are norm 1. So let me write it. So whenever doing this example, so for discarding B, C and D, I have chosen this to be norm 1 in R2. So all these are norm 1. Okay, now I am doing it in general. So then this will be norm of x plus y is 2. So this you can write 1 plus 1, and you know because x and y are in x0, so they are as norm 1. So this is we have to prove. So norm of x plus y is equals to norm x plus norm y. Right, so the first part is done. Now we have to show that x and y are linearly independent. So for that we use one result. So this is one result. I will not prove this one. So let me write one result. So the following are equivalent. Two statements I will write which are equivalent. This is the meaning. TFA means the following are equivalent. One, it is saying that if x and y is in x0, mean this unit ball, and x not equals to y, and tx plus 1 minus ty does not belongs to x0. Means if 2 points belongs to x0, then their linear means the convex combination, means line joining x and y, will not in that unit ball for t in 0 1, open 0 1, right? So this is sometimes called that, means the space x is not strictly convex. It is called x is not strictly convex. Means whenever 2 points lies in the unit ball and they are distinct, then their convex combination is not lying in that unit ball. So this is then the space is called, the x should be strictly convex. And what is the statement 2? It's saying that whenever norm of x plus y equals to norm x plus norm y for some x and y in x, then it's saying that whenever this will hold, then the 2 points should be linearly dependent for some alpha bigger than 0. So what this is saying, that space x is not strictly convex, imply that whenever that it will satisfy this identity, then the 2 points should be linearly dependent, and the vice versa. If for the space it satisfies this identity and they are linearly dependent, then the space will not be strictly convex, means their linear convex combination will not lie in the unit ball. So we will use this one to get our result. So in our case we have this. So in our case for option A, we have shown that this will hold, that for xy norm of xy equals to norm x plus norm y, right? This here we have shown that if they are two distinct points, then and the line joining between them is in x0, then this identity will hold, means this will hold. So here the statement is saying whenever this is saying, and suppose assume we have to, what we have to prove, that the 2 points should be linearly independent. So as assume that, also assume let's assume x and y are linearly dependent. Means y should be some alpha x for some alpha greater than 0. So it's satisfying this condition too. So it's saying that they are equivalent, means it's saying that one will hold, means if 2 points x and y which are distinct, then their line segments should not be in the unit ball. So then by the above result, for x y which lies in the unit ball and x not equals to y, tx plus 1 minus ty will not lie in x naught or t in 0 1. But this is a contradiction, right? This is our assumption for the statement that if xy in x naught equals to y, then the line segment is in x naught. So what we have assumed here, this one, that xy are linearly dependent. So this is not correct. So which is a contradiction. This does not, which is a contradiction. So our assumption is not correct. Therefore xy are linearly independent. Okay. So what we have got, that option A is correct and option B, C, D are false. So option A is correct. Other options are false. Okay. So we have done the question number 15 from Gate 2022. Here we have what? So we have defined the unit ball for a space X, a non-linear space, all such point which has norm 1, right? So that we have, and there we have need a one extra property that if X and Y are there, then their line joining between them. If X and Y and their line joining between them are there, it has the property, the space has property. So that is called then called the space is not strictly convex, and whenever any 2 points so that line joining between them is not in this unit ball, then we call the space to be strictly convex. So here I have given an example that R2 with L1 norm is not strictly convex. Means if you take that 2.10 and 01 line joining between them lying in the unit ball. But also you can check that R2 with L infinity norms are not strictly convex. Means you take 2.1 comma 1 and minus 1 comma 1, then the line joining between them also lie in that space. So therefore, so R2 with L infinity norm is not strictly convex. In general, you can show for Rn also. So then one norm and infinity norm are not strictly convex. So what are the strictly convex specs? You can show that for any p which is lying between strictly bigger than 1 and less than infinity are strictly convex space. Means if you take any 2 point, then their line joining between them will not be in that space. Basically, this is enough to check that their midpoint is not in there. It is equivalent. If their midpoint is not there, then the line joining between them will not be there. This you can also tell. And there is one equivalent criteria that I have written, that if the space is strictly convex and it satisfies norm of x plus y equals to norm x plus norm y, and then they should be linearly dependent if the space is strictly convex. Here it is in this question is given that a space is not strictly convex, so that's why it satisfies this condition norm of x plus y equals to norm x plus norm y, but the two different points are linearly independent, right? Yeah, this we can also you can check also the how the unit ball look like for convex or non-convex, still convex or not still convex spaces. Here what I have drawn that it is like rhombus kind of thing, right? For in one norm. In infinite norm it will look like a square unit ball. So it will passes through that point 1 comma 1 minus 1 comma 1 minus 1 comma minus 1 minus 1 comma 1 comma minus 1 in this 4 point. And other unit balls will lie in between these two unit balls. Yeah, but R2 basically in R2 unit ball is just circle, right? So this is the intermediate space in 1 in infinity. R2 again, R2 L2 norm, you can check that this is not, this is strictly convex. Take any 2 point, it will not, their midpoint will not in that unit ball. In the next class, what I will do, I think I will do from real analysis. Two questions from real analysis. Okay, so let's stop for today. I think we'll make the next week. Okay, bye.